Hello everyone, welcome to another episode from Chedexcel. Today I am going to talk to you about the very first chapter of A2, that is chemical kinetics. That is the very first chapter in unit 4. So, in chemical kinetics what we are going to learn in total wise is we are going to talk about the types of catalyst, right, and we are going to talk about how to measure the rates of chemical reaction, and then we are going to talk about the rate expression and the factors we can get from the rate expression, and finally how to find the activation activation energy of a chemical reaction. So, today the very first part I am going to talk to you about how what are the different types of catalysts. So, today's topic is effect of the catalyst, right. So, there are different types of catalyst. So, I will come back to that later after describing after discussing what we have done in AS level. Right. Before I start the A level work or the A2 works, I will quickly revise what we have learned from AS, or what you should know from AS about the chemical kinetics. Now, the basic idea that you have learned from IGCSE level is for a chemical reaction to happen, it should fulfill two, or in fact we can say three basic conditions. For a chemical reaction to happen, no matter whether it is slow or fast, for a chemical reaction to happen, the reactants should collide, and they should collide with the proper orientation, we say. And third factor is those oriented particles should have the minimum amount of energy to give the products. That minimum amount of energy to give the products is called as the activation energy. So, those are the three conditions to fulfill in order to chemical reaction to happen. And then we discuss in AS level and IGCSE also, you have what are the other factors that we can use to determine the rate of the chemical reaction, or the factors that affect the rate of the chemical reaction, and those are we learn temperature, concentration, surface area, and the catalyst, right. So, those are the basic parts what you have learned from AS. And then under the temperature we discuss about the Maxwell-Boltzmann distribution curve. If I quickly revise you, I think you can remember we draw the graph like this, right. Those are the basic part we learn. So, today we are going to talk about one of the other factors. There we discuss something called catalyst, and that part we never discuss in detail in AS level. So, today we are going to talk about the effect of catalyst of a chemical reaction, and that is the very first part that we are going to do in A2 syllabus, right. So, today we will see how the catalyst can actually affect or change the rate of a chemical reaction, right. Now, when you talk about the catalyst, the common general thing that we should remember is catalyst is a substance which speed the rate of the reaction without being used up. That is what we have learned from IGCSE level. Then how does it speed the rate of the reaction? We say catalyst can provide an alternative path with a lower activation energy. That is how we say the catalyst can speed the rate of the reaction. Now, even though we say catalysts are the substance which do not used up, it is not exactly correct. Actually, there are situations the catalysts are being used up during the process, and we just say it is not being used up because at the end of the reaction it is regenerated. But there are many instances that during the reaction process the catalyst itself is being used up. So, it is quite a remarkable thing to know that we decide or we say that catalysts are not being used up, but actually there are instances that we have seen the catalysts are being used up. So, in those examples, in those situations, if we remove the catalyst from the reaction mixture, the reaction stops. So, we are going to talk about one example later of this chapter as well, right. So, catalyst is something that does not used up. Why do we say it like that? Because it regenerates at the end, but during the reaction process it might get used up as well. So, this is something additional information I am telling you about the catalyst. So, to identify or to understand the effect of the catalyst overall process, I will tell you like this. So, we will take a common currency, I will take like dollars. So, let us say for someone say I want $100, can I borrow $100 from you? So, one say okay, I will give, and you give $100 for a person, your friend, and he say okay, I will return it tomorrow. Now, you give $100 bill, let us assume like that $100 bill you give, and the very next day he returned you with 100 $1 bills, right. He returned you $100, but with 100 $1 bills, and you get 100 notes of that. As long as you get the $100, we are not going to bother, but actually if we think what has happened to our $100, the $100 note, it's been used up. So catalysts are also like that. The way you add at the beginning of the catalyst might not be there at the end, but the amount wise or the concentration wise it would be the same, but it might not the same phase or the same state or the same condition you add. So catalysts are something like that. Generally catalysts cannot increase or decrease the enthalpy change, catalysts cannot increase the or decrease the amount of the products. What it does is it speed the reaction and it increase how fast it happens. So given a limited time period, we can get a higher amount of products. So when you talk about the catalyst, there are two types of catalyst. One is homogeneous catalyst, another one is heterogeneous catalyst. So first we will talk about those catalysts, and that is actually what we are going to do today. So homogeneous catalyst, if the catalyst and the reactants are in the same phase, we say that is a homogeneous catalyst. For example, the very common example, we use carboxylic acid and alcohol react together to produce esters. In this reaction, we use concentrated HCl or concentrated sulfuric acid as a catalyst. So ethanoic acid liquid, methanol liquid, the product you obtain, the ester methyl ethanoate is a liquid, water is a liquid, the H plus we add is aqueous. Now catalyst aqueous and liquid, the physical state wise the same. So that is what we call as a homogeneous catalyst. The homogeneous catalysts are very easy to use, and commonly in the laboratory what we use is homogeneous catalyst. The disadvantage of homogeneous catalyst in industry wise is it's a bit hard to remove it, because once we get the esters, we have to now separate the esters from the catalyst as well, as so all of them are in the liquid state. We have to have another process, something like steam distillation, or in this case fractional distillation, to separate the liquid from the reaction mixture. So if the catalyst and the reactants are in the same phase, we say it's homogeneous catalyst. So how does it speed the rate of the reaction? The general term, it provides an alternative path with a lower activation energy, right. But very commonly the catalyst we use in industry is something called heterogeneous catalyst. Heterogeneous catalyst. In heterogeneous catalyst, catalyst and the reactants are in different phases, or we say different physical states. So most of the time we use heterogeneous catalyst in industries. Example is we use nickel catalyst in hydrogenation of alkene, right. To convert alkene reacts with hydrogen to form alkane, we use nickel catalyst. Nickel in a solid state, alkenes are in normally gaseous state or liquid state. The physical states are different. So that is an example for a heterogeneous catalysis. And then there are many. We use nitrogen to react with hydrogen to produce ammonia, and we use iron or iron oxide Fe2O3 as a catalyst. So these are in gaseous state, catalyst is in solid state. So that is also an example for heterogeneous catalyst. So we will be talking about this heterogeneous and homogeneous catalyst again in unit 5, but here heterogeneous catalyst is something like this. The physical states are different. Now heterogeneous catalyst can also provide an alternative path, but we normally describe the effect of the heterogeneous catalyst in 3 points, something called adsorption and desorption. Remember, it is not ab, it is adsorption, AD, right. So it is adsorption. So what happens in a heterogeneous catalyst is the catalyst provide the active surface for the reactant to get attached to the surface. The attachment of the reactants to the catalytic surface is what we call as adsorption, AD, right. So, catalyst surface is there, we call them as active sites. The reactants come and attach to the surface, or we call it as they get adsorbed. And then rather than both reactants are moving, if a one reactant stays still, it is easier to have successful collisions. So, then what happens is when the collisions are happen, the bonds get weakened, and when the products are formed, we say the products get desorbed or desorption from the catalytic surface. So, that is how the heterogeneous catalyst increase the rate of the reaction. So, it gives the active surface for the molecules to get adsorbed, which makes the bonds to get weakened, and the products get desorbed from the reaction mixture or the catalytic surface. So, we can reuse the catalytic surface again and again. But again, even though we say they are not being used up, after some time we say the catalytic surface can get poisoned. So, we have to replace the catalyst. So, common example that we have to replace the catalytic surface is in vehicles, exhaust fumes. In the silencer we have something called catalytic converter. So, after a few years, like 8-10 years, we have to replace the catalytic converter, because what catalytic converter does is it converts the carbon monoxide or nitric oxide of the exhaust fume into carbon dioxide and nitrogen gas. We use platinum and palladium mixture as a catalyst there. So, after some time we say the catalytic converter is not going to work properly. So, we have to replace it. So, catalysts are not being used up, but the theoretical idea is the same, but with the time being they get consumed. So, we have to replace the surface, because we say the active surface can get poisoned. So, summary wise, how does a heterogeneous catalyst speed the rate of the reaction? It provides the surface or the active sites for the reactants to get adsorbed, and it makes their bonds weaken, and when the products are formed, they get desorbed from the catalytic surface. So, the adsorption, bonds get weakened, and desorption, those are the 3 points you have to write if they ask you about the heterogeneous catalytic process. So, that is the two types of catalyst we have, homogeneous and heterogeneous, and that is something we haven't learned in AS, right. So, that is it, that is the explanation of homogeneous and heterogeneous catalyst, and we are going to talk about in detail how these homogeneous and heterogeneous catalysts can actually affect the rate of the reaction and the mechanism, and I will explain it in another video. So, if this is helpful, consider subscribe the channel and give a thumbs up. Thanks for watching.